Hello viewers, in this video lecture, I will consider a problem of plane kinematics of rigid bodies. You can see a pulley and cable arrangement with a load L attached to the two pulleys which form a rigid body. This arrangement hangs from a cable which is securely wrapped around the two pulleys labeled 1 and 2. This implies no slippage. It is a good practice to indicate the orientation and the sign convention of the coordinate system chosen. We know the angular velocity, denoted by omega, and the angular acceleration, denoted by alpha, of the two pulleys that have pin joint connection with the ceiling. Based on this data and the information of the radial dimensions of all the pulleys in the system shown, we have to calculate the velocity and acceleration with which the load is moved upwards. We know that pulley 1 and pulley 2 are lifting the load L in upward direction but at different speeds. The displacement can be visualized like this, where point B will have more displacement compared to point A. A similar trend is observed in velocity diagram. The acceleration diagram, however, will be different. Remember from the data that pulley 2 is decelerating. We know that the arc length denoted by S is equal to the radial length into the angular displacement. In this example, the arc length denotes the distance the cable is pulled upwards. Differentiating the relation with respect to time gives us the velocities of the pulley arrangement at point A and point B. Now differentiating again, gives us acceleration. From the given data we compute the linear velocities of pulley 1 and 2 respectively. Similarly, the tangential acceleration is computed for the two pulleys. It can be seen that the velocities and acceleration of the pulley 1 and pulley 2 is the same as the velocities at point A and point B on the rigid body consisting of two pulleys. We thus substitute the known values and obtain the angular velocity and angular acceleration of the rigid body from which the load L is hanging. Now that we have the angular velocity and acceleration, we can compute the linear velocity and linear or tangential acceleration of the load which hangs from the center marked by O. If this video was helpful, then don't forget to like and subscribe.